And guys, so let's just take a quick look at naming ionic compounds. So naming ionic compounds. So there's some simple rules you need to follow when naming an ionic compound. We looked at in the last video that an ionic compound is an electrostatic attraction between a cation and an anion. Now, just to help with refreshing your memory, a cation is defined as a positive ion, whereas an anion is a negative ion. So a cation is a positive ion, so an atom that has lost an electron, so a positive ion, whereas an anion is defined as a negative ion, so negative ion. Now, whenever we join these together, an electrostatic attraction takes place. So we have an electrostatic attraction between a cation and an anion to form an ionic bond. So an ionic bond is defined as an electrostatic attraction between a cation and an anion So when a positive and a negative ion are attracted to each other, they form an ionic bond, which is an electrostatic attraction between them, and this then forms an ionic compound. So ionic compound, which can be defined as two or more ions or different ions joined together by an ionic bond. Okay, so a cation is a positive ion, an anion is a negative ion. An ionic bond is defined as an electrostatic attraction between a cation and an anion. And an ionic compound is when two or more different ions are joined together by an ionic bond. So hopefully you can see how those four things are joined and related. Okay? So, if we have a think about different anions and cations that can be joined or are joined to form ionic compounds, we could draw a table like so with three columns. In the first column, we could have cations. Second column, we can have anions. And third column, we can have the ionic compound it forms. So if we have the cations here, we have the anions, and in the third column we have the ionic compound formed. So the ionic compound that is formed from the cation and the anion we're joining together. You'll hopefully pick up that there's some different rules, there's some naming rules, okay? So for example, if the first cation we're going to start with is lithium. Lithium loses an electron, so it becomes a positive cation. And we say that the anion we're going to use is chlorine. So chlorine gains electrons, becomes negative, and is therefore an anion. The ionic compound we would form is lithium chloride. So lithium chloride. Now if our cation is sodium and our anion is bromine, again another group 7 atom, sodium and bromine would join together to form the ionic compound sodium bromide. If we do another one, we could have calcium, and we could have iodine. This would form calcium iodide. So calcium iodide. Now, if you look closely at this, if you think, there's 2 rules we can always follow. The first of which is that in a compound, if there is a single cation and there is a single anion, they all end in "-ide". They all have the suffix "-ide". You take the name of the metal or the cation, you then take the name of the anion. So if we have the cation here, that goes first. You then have the name of the anion, which in this case would be chlorine, and you add an "-ide" on the end. So we've got our cation, lithium, we've got our anion, chlorine, and then we've added "-ide" on the end as a suffix to create lithium chloride. Again, with sodium. Sodium is our cation, that goes first. Then we've got our anion, and instead of having this "-ine" on the end, we've replaced it with an "-ide". So sodium bromide. Calcium goes first, that's our cation, and then we have our anion and add "-ide" on the end, calcium iodide. So from this, hopefully, you can see that there's a couple of rules we can follow. Okay? So we could say that if the ionic compound contains one anion and one cation, it ends in "-ide". Now the other rule we can say is that the cation always comes first, followed by the anion, and then "-ide". So if that's our first part, our second part, or our second rule, is the name, help if I could spell, the name of the cation comes first. So you always put the name of the cation. Now, some of you may have noticed that the cation does always seem to be a metal. However, this isn't always the case because, for example, hydrogen is also a cation, but hydrogen is a non-metal. Okay? Now, we could add this to oxygen, for example, and this would make hydrogen oxide. hydrogen oxide. And as you can see, we've still got the name of the cation, we've still got the name of the anion, followed by "-ide". Okay? Now, this becomes slightly different when we have something that ends in "-ate". So, if a compound name ends in the word "-ate", so we'll do this in white so you can see, if the compound ends in the word "-ate", this means there is a cation an anion and oxygen. Okay? So if the compound ends in "-ate", that means there is a cation, an anion, and oxygen. So for example, if we have lithium chlorine and oxygen, this would be lithium chlorate. If we had sodium plus bromine plus oxygen, this would be sodium bromate. If this was calcium plus iodine plus oxygen, it would be calcium iodate, so on and so forth. You get the example. Now, we could theoretically have hydrogen plus oxygen. That would make hydrogen oxide. But because you can't have another oxygen, you can't say hydrogen plus oxygen, because you've already mentioned the oxygen. So you can't really have hydrogen oxide. You would only ever have hydrogen oxide. However, if you had hydrogen and chlorine and oxygen, you would have hydrogen chlorate. Okay? So